Okay, we're in section 5.2. We're working on the Gauss-Jordan method to solve a system of linear equations using matrices. In the previous video, we worked an example where I spent a fair amount of time talking about how and why we do each step in the process. In this video, I would like to work two more examples, and I would like to go a little bit faster through the process. And so if you're having trouble following along, it might be good to go back and watch the first video again to get a better or deeper explanation for the steps that we're doing. Okay, oh, the other thing you might want to do is pause the video and try to work these problems for yourself. Okay, so let's look at example 2, and the first step is just to convert the system of equations into matrix form. And so remember, we use brackets to show the matrix, and we use a vertical line where the equal sign would be, and on the left side we just write the coefficients on the variables. So in the first equation, 3, -4, and 1, and in the second equation, 5, 2, and 19. And remember, each row represents an equation in the system. And so then we're going to go column by column from left to right. So in the first column, we need to get a 1 on the diagonal. And we do this the same way almost every time. We just multiply that row by the reciprocal of the number we're trying to make 1. So this 3 needs to be multiplied by 1/3, and so we'll multiply the entire first row by 1/3, and we'll get 1 and -4/3 and 1/3. And the second row is not going to change. You know that the next step is to make a 0 where this 5 is, but we don't want to do that in this same matrix. We want to just change one number at a time for now. So we made the 1 in the first row, and we just copied down the second row. Okay, remember, as we change this matrix to diagonal form, we're going from left to right, column by column. We get a 1 on the diagonal, there it is, and then we get zeros off of the diagonal. So that's the 5 right there. And when we're making zeros off of the diagonal, we do it the same way almost every time. The first row this time is not going to change, so I'm just going to copy it down. And then in order to make a 0 where the 5 is, we're going to multiply the row with the brand new 1 on the diagonal. We're going to multiply row 1 by the opposite of this number. And so that would be -5 times row 1, and then that just gets added to row 2. And so it would be worthwhile if we came out to the side and showed just what that looks like. So column by column, we're going to do -5 times the entry in row 1 plus the entry in row 2. So that would be -5 times 1 plus 5. That's the first entry. And we can go ahead and write 0 there, and we can put a 0 in our matrix. And then we're going to do the same thing for the other columns. So -5 times -4/3 plus 2. And then this is a good time to be comfortable with fractions, with multiplying and adding fractions. If you're not, you might check your work in a scientific calculator, or you might try to do the calculation in your head first and then check it on a scientific calculator. This is +20/3 plus 6/3 is 26/3. There will be fractions in these problems, and so we're not going to get away from them. So we just want to handle the fractions head on, so to speak. Okay, the last column would have -5 times 1/3 plus 19. So that's -5/3 plus 57/3 is going to be positive 52 thirds. Positive 52 thirds. And so here we have finished the first column, and we have a 1 on the diagonal and a 0 off the diagonal. And so now we want to go on to the next column. We want to proceed in the same way. We want to get 1 on the diagonal and then a 0 off of the diagonal. So diagonal goes through 26 over 3. To make it 1, we multiply by the reciprocal. So that will be 3 over 26 times row 2. And that will give us 0, 1, and then 3 over 26 times 52 over 3. You might want to write that off to the side. There's a common factor of 26 that cancels and come out to a nice answer of just 2. And so then we have 1, negative 4 thirds, and 1 third that we leave alone for now. And we're finished with the next step. So in the second column, we got 1 on the diagonal. Now we'll get a 0 off of the diagonal. And so we're going to multiply the row. Let me slow down for just a second. The second row looks good. It's the first row that needs a little work. We need to make a 0 where the negative 4 thirds is. And the way we're going to do that is we're going to multiply the row with the brand new 1 by the opposite of the number that we want to cancel. So that means multiply 4 thirds times row 2 and then add that on to row 1. And it would be good to come out to the side and to see what those calculations are. So column by column. In the first column, 4 thirds times 0 plus 1. 4 thirds times 0 plus 1 is just 1. 4 thirds times 1 plus negative 4 thirds is 0. All this looks real good. And then on in that last column, we have 4 thirds times 2 plus 1 third. That's 8 thirds plus 1 third is 9 thirds, which is 3. And so there we have it. So now we have the matrix in diagonal form, and we're ready to read off our answer. The first row says x equals 3. And the second row says y equals 2. And we could write that as an ordered pair, 3, 2, and we're done. You might go back and check that your answer is valid by plugging it into both of the original equations. And we can go on to the next example now. So let's go to example 3 here. Again, if you're feeling good about the process, you might want to go ahead and try to pause the video and work the problem for yourself. Let's write the system as a matrix. And then we want to get a 1 where this 3 is, and we could just multiply the first row by 1 third, and that would be fine. I would encourage that. But this is one time where you might be able to avoid the fractions if you use a different transformation. And so in particular, there are there are 3 row transformations that we can do. Um, you saw 2 of them in the previous examples. Multiplying any row by a number that's not 0, or multiplying a row by a number and then adding it to another row. Those are 2 of the row transformations that we've learned. There's a third row transformation, which is just to switch 2 rows. And so let's do that. Let's write the second row first and the first row second. And out to the side, let's just write switch row 1 and row 2. And then the nice thing about that is that we can get a 1 there in the first column, first row, without getting fractions. So all we have to do now is just multiply the first row by -1. So we're going to do -1 times row 1, and we'll have 1, -1, and -3. And the second row just gets copied down. So that was the big idea that I wanted to show you. It's not really that big of an idea, but that's the thing I wanted to show you in this example. The rest of it should go pretty smoothly. We'll make a 0 underneath the 1. To do that, we'll do -3 times row 1 plus row 2. The first row just gets copied down. The second row is going to be 0. And then it's going to be 3 plus 2, which is 5. And then it's going to be 9 plus 11 is 20. If you can look ahead, if you know what the next step is, you can see that the numbers are coming out nice. The answers, I think, will be integers in this problem. And they're not guaranteed to be, but if you're getting some really ugly fractions, then there's a good chance you've made a mistake. It's easy to make mistakes it's easy to make a careless mistake as you're going through the calculations. Okay, so in the next step now, we finish the first column, we go to the second column, we put a 1 on the diagonal. How do we do it? Multiply row 2 by 1/5. And that will give us 1 and 4. And we can see that y is equal to 4. I would also point out that there are variations on the Gauss-Jordan method. So in our pre-calculus class in a couple semesters, we'll stop right here with the matrix we just got, and then we'll finish the problem by a slightly different method. But for now, we're emphasizing Gauss-Jordan method. We're emphasizing getting the matrix into diagonal form. This is not in diagonal form yet, so don't stop here. Go on and get a 0 in the second column off of the diagonal. So to do that, remember we multiply the second row by the opposite of the entry we're trying to cancel. And so the opposite of -1 is +1. So you could write 1 times row 2 plus row 1. Or you can see that's the same as just row 2 plus row 1. And so when you add the 2 rows together, you get 0, you get 1, and then 0, and then 1. And so here is our diagonal form, and we can write the answer: x equals 1, y equals 4. And we're done.